Thank you for the introductions. So my name is Akihiko Murai from AICT Japan. And today's topic is digital human technology. So I have been developing the human musculoskeletal model that is one of the digital human model and analyzing the human motions. So today I would show how this digital human technology designs and improves the human's interactions. So the digital human technology consists of the digital human model and the quantitative motion representations. And we have been developing the humans modeling, the digital human model, and the motion measurement technology, and the kinematics and dynamics analysis algorithms. So at first, we developed this human musculoskeletal model. So the musculoskeletal model is one of the digital human model, consists of the skeleton model and the musculoskeletal network. The skeleton model consists of the linkages and the mechanical joints. And the musculoskeletal network is modeled based on the anatomical knowledge. So this model represents the human's kinematics, dynamics, and anatomical characteristics. And this model can be individualized based on the human's measurement dataset and some inputs. For example, in this case, we just input his height and his weight. And the statistic analysis of the large human measurement dataset can estimate the detailed human shapes. And this is our latest human volumetric musculoskeletal model, in which we model all the bones and muscles and skins with the anatomical shapes. And this detailed modeling realizes more accurate human motion analysis. So we measure the human motion using the commercial optical motion capture system, the force plate, and the electromyograph. The experiment with these equipment in the laboratory can realize the accurate motion measurement. But this tense atmosphere may change the human's behavior, and it may become difficult to measure the human's daily natural motions. So now we are developing, Now we are developing the technology to measure the human's daily behavior with the context. So this simple sensor measures the small part of the hand shape, and the human hand motion dataset reconstructs the detailed hand shapes. So we can implement such simple sensors to the product or to the environment to measure the human's daily natural behavior with context. And the measured human motion is analyzed based on the kinematics and dynamics computations. So inverse kinematics computations compute the human joint angle that represents the human's motions. And the inverse dynamics compute the joint torques here. And we distribute this joint torque to the muscle tensions. And the difficulty is that we humans have significantly redundant systems. That is, we have much more muscle than our degrees of freedoms. So we need to apply the mathematical optimizations, for example, that minimize the quadratic sum of muscle tension to estimate the identical muscle activity. So in this movie, the muscle color changes from green to red when it is activated. So these analyses can also estimate the interaction between the human and the running-specific processes. So these models and algorithms are implemented in these physical function analysis and simulation software. For example, SIM and N-bodies are well known, and I have been working on this software, N-motion and DAY1. So this digital human technology analyzes the human himself, as well as the interaction between human and his body, human and human, and human and product, and human and the environment. And this analysis quantifies the human interactions and design and improves them. So from now, I show how the digital human technology designs these interactions with showing some examples. So first is about the interaction between human and the product. So these days, the product function and performance are increasing, but the perceived value does not increase so much. So this phenomenon is often called Webb-Hechner law. To improve this product value, we need to consider the interaction between the human and the product that realize the better user experience. So conventionally, we perform the user testing to estimate the interactions, though it costs a lot to prepare many product samples and human subject. And the data human technology replaces this user testing with the simulations. So with modeling and analysis techniques, we need less cost for product samples and human subject. So first, we measured many dimensions of the human's hand and create the large data set of measurements. And the digital human model is individualized. So here we just input the hand length and hand thickness, and it reconstructs the detailed individualized hand model. And the human motion is measured using the commercial optical motion capture system, and the inverse kinematics computation synthesizes the motion of the digital hand model. And with this synthesized human motion, we analyze the interaction between the human and the product quantitatively. So the volumetric digital human model and its motion estimates the contact area between hand and product. And we can also estimate the grasping stability from the synthesized hand posture. We still need some assumptions. For example, the larger contact area results in more comfort at the grasping. These quantitative analysis estimates the subjective assessment from kinematics and dynamics. So in this way, the digital human technology can improve the product design so that the subjective assessment about the interaction between human and the product becomes better. So next is about the interaction between human and himself. So that is the interaction between his brain and his body. So this is the application musculoskeletal see-through mirror we developed. So this mirror visualizes the human's muscle activity based on the data human technology and real-time processing. So he has the impression of seeing his muscle with tension information through his clothes and skin. So we call this application see-through mirror. So please think about the task of controlling a specific muscle. For example, one erector muscle of spine around back. So we humans send a motor command signal from brain to muscle, and it appears as a motion. So as you hear, it is very difficult to recognize each muscle activity, though we can recognize our own motion relatively easily. Therefore, it is difficult to control one specific muscle for us. And the application, musculoskeletal see-through mirror, the one of the data human technology, estimate and visualize the muscle activity from the measured motion in real time. So this application visualizes the relationship between the motion and the muscle and feedback it to human. So with this application, we recognize our own muscle activity through the motion that is relatively easy to recognize. So this application makes these connections so we humans can recognize our muscle through these pathways. So we can map one specific muscle's activity to one specific motion and run the skill to control this one specific muscle activity. So in this way, the data human technology modifies the interaction between the brain and the body and realize our easier control of our bodies. So last is about the interaction between human and the environment. So we have many stimulations from the environment, and react to them using a nerve system. That is the combination of a voluntary system and a reflex system. So by considering the human as a large system, the system identification approach can be applied to identify the system between the input from the environment and the output, that is, our motions. So we built the data human model that has the musculoskeletal model as well as the neuromuscular network. So the neuromuscular network represents the anatomical nerve connection between the spinal cord, muscle, and the receptors. So this network's input is a small sensory information that is sensed by the receptors. So human has a muscle spindle and Golgi tendon organ as the receptors, and they sense muscle length, its velocity, and tensions. And this network's output is in muscle activity. So the motion analysis with the data human technology compute these informations. And we identify the network's parameters from these informations, and identified system works as a motion controller that generates the human-like motions. So we identify a neuromuscular network with human locomotion data, and the identified system realizes the human-like response to tripping. So human's response to tripping changes depending on the phase when he trips. So one is the elevating strategy in the top, and the other is the lowering strategy in the bottom. So at the elevating strategy, human trips at the earlier phase of the swing phase. And we respond to that tripping by elevating the swing leg to keep balance. And at the lowering strategy, human trips at the later phase of the swing phase. And we run the swing leg as soon as possible and keep balance with the stance leg. The response of a neuromuscular network for locomotion also changes in the same way and generates a human-like response to tripping. So the interesting point is that we didn't use the response of tripping for the identification of the network, but the network that is identified from the human's locomotion automatically generates and realizes the human-like response to the tripping. So once we identify the data human system, a simulation to a human can be designed so that he performs a desired motions. So this framework can be applied to the prosthetic design and the superhuman sports. And this digital human technology augments the human's performance using the interaction between human and the environment. So as I talked today, we can design and improve the interaction between human and the other things by implementing the data human technology around us. And now the environment is ready to implement the data human technology around us. So the information terminals and IoT devices are implemented in many places, and they measure the human as well as the product and the environment. And the data human technology with this data analysis, the human with this data analyze the human interactions and designs and improves these interactions. So with this framework, I believe that the data human technology realizes healthy and comfortable interactions of humans for the healthy and comfortable society. So thank you for your attention.
Thank you so much, Murai-san.